Okay. Okay, let us continue. Then, because x approaches from the right side, it means that the absolute value of x is x. And the denominator, we just rewrite it. Nothing special, right? Now, x divided by x will be one, right? Limit of a constant is that constant. But now we see the left side hand limit is -1, but the right hand limit is 1. What does it mean? It does not exist, right? It approaches from both sides, and these values are not identical. Okay, does not exist. Is it clear? How about people on Zoom? Is it clear?
Yes.
Very good. So now let us consider another example, a branch function. So f of x is defined as x squared plus 1 for x smaller than 1, and it is x minus 2 squared when x larger or equal to 1. So we need, if the limit of this function when x approaches 1, if it exists, what is it? If it's not, prove it. Okay. Again, we need to find the limit of this function at 1. So we need to find the left-hand limit and the right-hand limit. If they are equal to each other, then the limit does exist. Otherwise, the limit does not exist. Okay? So again, our job is to compute left-hand limit of this function when x approaches 1 from the left. Okay? Then if x approaches from the left of 1, which branch should we use? Yes, very good. Because we are considering this. That is why we plug this value of fx into this. It means that it is limit of x squared plus 1. Okay? So limit of sum is a sum of limit plus limit of 1 when x approaches 1 negative. And then this is a polynomial. It is well defined. So it will be -1 squared, and the constant would be a constant here. So -1 squared becomes 1. 1 plus 1 would be 2, right? Therefore, this is 2, and the right hand limit of this is the limit of this function when x approaches 1 from the right side. Okay, this is x squared, right? The function is x squared. Very good question. So be careful. So we can substitute this value into this because it is well defined over the R, the real lines. So it is okay to put in the value of this. Okay. That is why we have -1. Oh, sorry. My bad, my bad. Ah, you're right. This is simply 1. I messed it up. Yeah. Okay, this is 1. Oh, writing negative and it confused her, right? Thank you for your correction. Yeah, it happens to everyone sometimes. Very good. Then, now, it is the limit, okay? Because it approaches from the right side of 1, it means if x is positive larger than 1. So we need to use the second range here, right? Where it is x minus 2 squared. So f of x here in this case is x minus 2 squared when x approaches 1 plus. Yeah. Okay. Now it means that we put this value into this. So it is -1 squared, which is 1, right? We see that the left hand limit is not equal to the right hand limit. Therefore, the limit of f of x when x approaches 1 does not exist. Okay? Is there any question? Very good. So now there's a theorem that if the function f of x is smaller than the function g of x, when x is near the point A, and both the limit of f and g exist as h approaches A, then the limit of f of x when x approaches A smaller than limit of g of x when x approaches A. It means it reserves the inequality. Applying this theorem, we have a Hamburger theorem, or we call it the squeeze theorem. It states that if f of x smaller or equal to g of x, smaller or equal to h of x, and f of x approaches L, h of x approaches L here, right? Then g of x should also approaches L here. Or we write it this way, limit g of x equal to L when x approaches A. So the smaller guy and the bigger guy approaches L, then the middle one should also be approaching to L. Just below that limit, or the name of the squeeze theorem, or I normally joke, the hamburger theorem. Okay, so squeeze to a point, right? Now, an example. Let us consider this. Okay. If we show that the limit of x to the fourth times cosine 2 over x when x approaches 0 should be 0. We need to prove it. Look at this. If someone showed this problems like this, limit x to the fourth cosine 2 over x when x approaches 0 from product rule, he wrote this. He wrote that, he write limit of x to the fourth, x approaches 0, limit of a product is a product of a limit, right? And because at the origin, when x approaches 0, 2 over x will goes to infinity and it's fluctuated so much. Therefore, the limit of this guy does not exist. We know that. Okay? And then he concludes that no matter what it is, this does not exist. Multiply with something here, and he concludes that it does not, the limit does not exist. What do you think about this? Think about it. It is not true, indeed. So, we can apply this squeeze theorem into this problem. Okay, if you don't remember the trig function here, we know that Suppose this is the unit circle. This is cosine axis. This is sine axis. And the maximum value of cosine will be 1. The minimum value of a cosine function is -1. So we know that for any function, cosine of x, it should always be between these two numbers for any x. That is a properties of trig function. So similarly, -1 should always be smaller than 2 over x, no matter what it is, and smaller than 1. Because this guy is smaller than between -1 and 1, and we know that x to the 4th is always larger or equal to 0, right? Something to the 4th is always positive. Therefore, the product from these two, we say that the product, we multiplied x to the 4th to both sides of these inequality. Multiply with x to the 4th and at the center. The inequalities whole. Okay, this is always true. Therefore, we can now let us take a look at try to apply this theorem. Look at this. Now we are trying to compute the limit when x approaches 0, right? Then this is our f, g, and h, right? This is our f. This is our g. And this is h of x from the previous theorem. Okay, now let us compute limit of -1 times x to the 4th when x approaches 0. And what is this? This is a polynomial. It is defined at any point in the real lines, right? So compute this limit. We can simply substitute this value into this. And it will be -1 times 0 to the 4th, right? Or simply 0. Similarly, the limit of x to the 4th when x approaches 0 will be the same story. 0 to the 4th, and it is 0. So from the squeeze theorem, we know that it should be 0. Okay? Is it clear? okay? It means that this whole thing here does not make sense. Okay, be careful. I'm going to give you some more examples so that you can work at home. Consider this and find the limit when x approaches 0. It will be similar, right? And now, look at this. It is in the homework from website. We are given that the limit of function f of x minus 6 divided by the denominator here when x approaches 1 is given, which is 9 in this case. They ask us to find the limit of the function f of x when x approaches 1. Okay. In order to deal with this problems, let us write what we have and see what we can do with that. We are given that limit of f of x minus 6 divided by x minus 1 when x approaches 1 is given, is 9, right? If we multiplied both sides by this number, nothing's changed. So limit of x minus 1 when x approaches 1 will be simply 0, right? We multiply 0 by both sides. It's okay, right? Then look at this. From this, we reverse the product rule and see what we have. The right-hand side becomes 0, right? And the left-hand side is equal to the limit of the product f of x minus 6 divided by x minus 1 times x minus 1 when x approaches 1, right? The product rule. And now, be careful, this is a bracket. Now we see that the product of these guys will be the product of this times x minus 1 divided by the denominator here. And we know that the numerator has x minus 1, the denominator has x minus 1, so they cancel each other. It means the limit here becomes limit when x approaches 1 of f of x minus 6, right? It makes sense from product rule. And now, this is the difference. Limit of a difference is the difference of a limit of limits. Right? This rule, and here is limit of function f(x) when x approaches 1. This is the limit of a constant will be this constant. Okay, after a long computation, we know that the left-hand side is this guy. And the right-hand side is simply 0 right here. Okay? Therefore, and the left-hand side equal to the right-hand side. Therefore, we know that limit of f of x here when x approaches 1 minus 6 should be equal to the right-hand side. And now we add both sides with 6. Therefore, we have the limit of the function f of x when x approaches 1 will be 6. Is it clear? Is there any question? How about people on Zoom? Is it clear for you? Is it good? Okay, now let us move on to another topic. Let me first stop reading.